So how many folks are primarily skiers? Primarily sledders? And both? How many people are? Okay, that's good, because that's kind of where we're going here, is the stress in the snowpack. And mostly I'm going to talk about measured stresses in the snowpack underneath skiers and sledders. And Scott Thumlett is the graduate student who's done this work. But I'm going to go back to a little bit of work with Alec here first. And we got him he pushed me pretty hard actually, and we got him a video camera. And so he was doing tests like this with Cam Campbell, and there's a weak layer of surface hoar between these two rows of dots. This is actually not the high-speed camera, which is coming soon, but so let's just look at Cam Campbell trying to start an avalanche in this piece of the snowpack. Come on, Cam, give it a good shot. Okay. So, and next, we're going to see Alec's first high-speed camera, and this is the resolution of this. This thing cost me $10,000. It broke my budget to get this kind of resolution. So this is the same ski cut coming in. Okay, the two cameras are running simultaneously. You see the upper dots move, the lower dots don't, and these bottom dots don't move. The fractures comes down through here and stops for no reason that I've ever been able to figure out. Okay, so fractures initiate, sometimes propagate, and sometimes keep propagating far enough to release the avalanches. And maybe I'll just run that one more time, okay, and see if you can see which dots move and which ones don't. Okay. Well-developed surface hoar layer in there. Okay. So this process of fracture initiation, fracture propagation, and then sustainability far enough to release an avalanche is really important. In this talk, only talking about the initiation, the stress that initiates the fractures. And as we know, the human triggers, the skiers, the snowmobilers, or whatever, and Bruce Tripper is quoted as 98% in some places. So, okay. Now, I'm going to look briefly here at calculated stresses. So this is we assume elastic snowpack, put a load on each of the skis, and this is the stress underneath. And here, if we look down about a meter in the snowpack, we're seeing about 450 pascals underneath the lower ski, which has more stress on it. If we look at the snowmobile going up the slope, let's go down about a meter, and we have something like 1050. So we have about twice as much stress underneath a snowmobile going up the slope as we do a snowmobile going across the slope. And that's before we take into account the spinning track, the penetration, or anything else. There's just more stress when you're going up the slope than there is when you're going across the slope. And that's based on a bunch of assumptions: no penetration, elastic snowpack, etc. Okay. Now, Scott set out to measure it, and actually Thomas Exner before him. So we have some pressure sensors out here, capacitance sensors. It's about 5 centimeters by 5 centimeters. Each one of those you can press on them with the thumb and see the reading, and puts them on. And there's another one back here, and pushes them into the snowpack, and then measures the increase in stress when you take a skier, a snowmobiler, snowshoe, or a hiker, whatever, over top of these things. Okay. So here they are, pushed into the snowpack, and they're back directly underneath. The sensors are underneath this, and then the data logger's in a backpack in here that measures the stress. And video time. So this is a snowmobile. And you might be saying, well, what about cornering hard? And we haven't got there yet. We're just doing it the really simplest of situations here. And we've done a lot of those. Okay? And skier. So the skier down weights, and we're trying to create the stress of turning. Part of a turn involves down weighting, so the skier down weights and the snowmobile just is normal accelerating up, fairly constant speed up the slope. So their penetration is quite different. The snowmobile is in most cases different, quite a bit deeper than the skier, and you might say, well, that's not a fair comparison, but we think that's fair for the actual triggering. And I'm going to show you the results with and without penetration. Oh, I got one more. And this is the one the snowmobilers like first. This is the falling skier. You go to a snowmobile meeting and they play that one over and over again. Okay.
I look like Shabbat.
That was me, actually. Okay. So this is for 2 specific days where we're measuring the stress underneath skiers here in the gray and snowmobilers in the white, and there's a bunch of passes here, which is why there's a distribution here. And on 2nd of February, the skier is around 1 and the snowmobiler is median around 4. And here we see a substantial difference as well on the different snowpack conditions on January 25th. So substantially more stress underneath the snowmobile than underneath the skier. If we put a whole bunch of different data together and then fit curves through them, again, the white here is the snowmobiler, and in this triggering range that we're interested in, say 80 centimeters and less, we see substantially more stress, 2 to 3 times more stress underneath the snowmobile than underneath the skier. And that's with, and the snowmobile is penetrating the snowpack more than the skier. These lines should be vertical, actually. So now we're going to take into account the penetration, and we're going to work with the effective depth, because after each time the snowmobile goes by, Scott measures the penetration depth. So if we subtract that off, we have the effective depth down to the sensor. Right. And now, again, snowmobiler is the white, skier is in the gray, and the two are pretty much lined up all together. So if a skier and a snowmobiler penetrate the same, they produce about the same stress. And if you actually calculate the surface stress, just the weight per unit area for either of those, it's also about the same. If you take penetration out of the equation, it's also about the same. Okay. The big difference is whatever penetrates more between these two creates more stress. Okay. And like I say, our skiers are always coming down, pushing down on the sensors, and our snowmobiles are going up, and just kind of normal amount of track spinning going on for soft snow. And there's measured penetration here, much more penetration here, median up around 50 centimeters, and the skier has got a median around. So there's about twice as much penetration underneath the snowmobile and 2 to 3 times more stress underneath the snowmobile. And that's what we're measuring. Now you can take snowpack properties into account, and Scott's got another paper and another video online about that, but I'll skip that. But he's actually calculated the bridging. I know it's a controversial term, but if you take in the hardness of the layers as well as the thickness of the layers, that's how he deals with snowpack properties and gets a better correlation with the bridging index and stress than you actually get with depth and stress by taking into account the hardness of the individual layers. And that's maybe enough on that. So Scott had this idea that our penetration is not well represented in our snowpack tests that we talked about. Now, I'm not sure we needed another snowpack test, but that's Scott thought we did. So thought if you should subtract off whatever your penetration is. So if your snowmobile is penetrating 40 centimeters, take 40 centimeters off the column. If you're landing big air penetrating 80 centimeters, you should take 80 centimeters off the column. and he called it a triggering test. So there's what the column would be if you didn't take anything off. If you did take something else, it would be like that. And because you're tapping deeper in the snowpack, you'd get more stress deeper as you do in the deep tap test. But in this case, you're taking off an estimate of the penetration. So take that off there, and we just have the green column. And you're going to get stress down deeper in the snowpack. So here's what we have, a bunch of measurements underneath the snowmobile, and they're obviously much higher for the shallow in the snowpack that the sensors measure. Here's the compression test, which is really quite comparable. There are similar numbers we're seeing for the stress underneath. These are the hard taps in the compression test using the same sensors, or shortened versions of the same sensors. And so you're seeing similar stresses, but there's a reasonable possibility that probability that you're going to miss. Sometimes you're going to not fracture the weak layer in the compression test that you are going to fracture in the snowmobile might fracture. So why not be on the err on the side of caution and take off the penetration depth. And there's the triggering test results here in green. And you see the increase in stress for the triggering test, for the hard taps in the triggering test. And so you're much more likely to fracture the weak layers in the triggering test than in the compression test than you will for the compression test by itself.
You're saying those compression test scores come from the hard taps from the shoulder?
Yep.
Okay.
Yep. Everything here is both for the triggering test and the compression test. The hard taps are what's being shown on this graph. And that's kind of it. So allowing for penetration, we see 2 to 3 times more stress underneath snowmobiles in the soft snow mountains of the Columbias. And it's strongly dependent on penetration. And you can just about equalize the skier and the penetration stress by equalizing the penetration. And Scott has worked a little bit with this triggering test for snowmobiles and for landing big air or whatever. But I'm not sure the world needs another snowpack test. And he does have another video and another paper here on taking into account the snowpack properties. And the hardness of the layers is really, really important in terms of the stress that penetrates to a specific depth. Questions?
So, one of the things that we've sort of noted here a long time ago was that, you know, people are always talking about, oh, these snowmobiles are so much easier to trigger an avalanche with because you have this giant snowmobile and you're riding it around and everything. But our experience has been that when snowmobilers are triggering avalanches, so are skiers. And when skiers aren't triggering them, snowmobilers usually aren't triggering them also. And I'm wondering, like in Canada, are you guys seeing that same sort of correlation, or do you see, I mean, have you talked to some of the forecasters? Are they seeing sort of a period where skier triggering is unlikely, but you got snowmobile triggering?
Certainly I haven't seen it. I've talked to a little bit to the forecasters, and they say they're not comfortable saying snowmobilers are likely to trigger the surface soil layers, but skiers are not this weekend. You know, they don't want to touch that. So, and it could be because triggering is so dependent on, well, for shallow layers, when things are right and the layers are shallow, everybody's triggering avalanches. And when they get deep, it's so dependent on thin spot triggering, which is complicating this one here, and the skier or the snowmobile can hit a thin spot. So I'm not aware of a big trend in terms of actual triggering. But the stress, if you make the snowpack conditions uniform, then there is more stress underneath the snowmobiles with kind of normal penetration. But in terms of triggering in the data, I don't know.
Yeah, well, it's made me wonder about the role of propagation and stability, because I've kind of wondered, well, you know, if it's just about, you know, can you initiate a fracture? It seems like you can probably initiate a fracture more easily with the snowmobile, at least in some cases.
Yeah.
But, you know, if that stability is a lot more tied into maybe that propagation propensity, then that might be why.
Yeah, that's a great point there, that everything here is about the stress underneath the snowmobile and a skier, and nothing about propagation is in Scott's study, so, yeah.
So in hard slap conditions where we're not going to penetrate really skis or snowmobiles, you say that the stress is then going to be pretty similar because of not penetration. Is that
We're seeing similar stress in the hard taps under a compression test as we are underneath the snowmobile.
Yep.
And so Scott's saying to be reasonably confident you're going to fracture the layer underneath that the snowmobile would initiate a fracture in. Why not remove something equivalent to the snowmobile penetration? Yep.
I think what Ian's asking, and correct me if I'm wrong, is all things being equal, if you have a hard slap, that snowmobile's barely penetrating and certainly a skier's barely penetrating, the stress input to that snowpack is very similar
Yes.
between a skier and a
Yes.
snowmobile.
Yeah. And we've done another set of measurements that Thomas Exner did that I didn't show here. We went out one day and we compacted the slope. We sidestepped on the slope, let it age harden overnight. We went out there with the next day and skiers and snowmobilers, and snowmobiles were like 10% more. It was essentially the same.
That's pretty counterintuitive
Um,
to me, anyway. Maybe I don't know.
No. I think that's why it's good to go out there and measure it, because yeah.
The one thing there is that the tractor has the bigger, wider tires on it, so it doesn't compact the soil as deeply. So that might be part of it. My question has to do with your test configuration. Could you put a few longer wires and be able to evaluate the explosive stress of an explosive charge where you, in relation to a skier and snowmobiler?
Yes, could do. We have not done that, but yeah. And we've done some with snowmobilers, and we saw falling skiers and hikers and snowshoers and whatever, but those are quite small data sets. I just focused on the skier and the snowmobile here today, and we've not done any explosives, and we don't actually have any plans to, but maybe
You can ask Dan Miller.
Dan Miller is the guy to ask. Yeah, Doug.
So penetration is the real difference between, the two, and more penetration, more stress.
Yep. And thanks for the fat skis yesterday.
Oh yeah. It seems like there's a lot of times when, just in real world, where you're gonna ski a run, fresh powder run, or you're gonna ride up it. The penetration difference isn't on the order of like 2 or 3 times different. It's a lot less than that.
Yeah.
And especially if you're looking at making a turn on a ski, like how far are you going in, and then like someone zips by on the sled. It's not like one is, really deep and the other one isn't.
There's quite a bit of data behind what I showed there for the penetration depth and for the stress underneath the skier and the snowmobile, but everything's the soft snow in the Columbia Mountains, okay? And if you get a different snowpack, it's going to be different. Yeah. We took to this very, simple situation of the skier down waiting and the snowmobile climbing, and you see the snowboarders out there with their ear practically in the snow, and they're creating all this shear in the snowpack, whatever. We didn't do that. We just one really simple test configuration. Yeah.
I think what's counterintuitive, bringing up Mike's point, is that last season in the United States, just the U.S. alone, 25 people died in avalanches, and there was 1 snowmobiler in the entire country.
Wow.
So I think that was a pretty stunning stat, actually. So, even though snowmobilers, I read some of the advisories from other forecast centers, and people do say avalanches may take bigger triggers today, like a snowmobile or a cornice drop. Like, people actually venture down that road in some forecast centers, but I think it's, like you said, we don't want to go. It's hard to make that statement, as a forecast center. But last year, I don't know, just that number, that one sledder in the entire country died last year when a lot of skiers were dying.
Yeah, I think if you look in Canada, we've certainly had years where the snowmobilers have been well ahead of the skiers killed in avalanches, but I think if you start looking over 10 years, they're pretty comparable, actually.
So basically,
You think the difference might be because just snowmobilers cover a lot more ground, and the chance of hitting sweet spot is higher?
Yes, and on the steeper slopes there, and you watch high marking, whatever, and you know, and the penetration's really, they're penetrating a lot when they're high marking. Yeah, and yeah, they hit more grounds, they hit more start zones, they hit more thin spots, and yeah, and certainly they move faster than I do on skis.
Well, and they'll go up the hill and then they'll get stuck, and so then you'll have a person who's post holing at the same time they're yanking this 500-pound machine around that's already, you know, buried in.
Yep.
We see a lot of people triggering that.
Yep.
Yeah, I think Carl's got a point on that boot. We don't talk about that boot penetration, you know, come around, it's the penetration like what you're talking about.
Yep.
You want to know how far you'll be able, I know maybe you guys might not, but I fall sometimes like that.
That was me.
But yeah, you know, even this year I had a guy ski the slope, lost the ski at the bottom of the slope. As soon as he walked up to get his ski, boot goes in, triggers. You know, once he would have never penetrated it on his skis. And then, you know, just that boot penetration sometimes I think is,
Yeah, and if someone comes
stutters dig them out.
and if someone comes up to help the person who's stuck in the snow, so you've got 2 sleds and 2 people on foot. Yeah, Mark.
Bruce, what are your thoughts? I mean, I've had the exact opposite scenario where I've booted up something safely or luckily, and then gotten caught once I put my skis on. And I think a lot of times early season, snowmobilers can be trenching through the depth door, and the skier will be just on top of the slab. And I'm just wondering, I'm kind of posing it to you, Bruce, or anyone really, is like, how exactly are we triggering these things? Do you actually, it seems to me, it's not about actually touching the weak layer. It's about starting some process that, like Carl's talk, involves a slab and a weak layer. And just like when the snowmobile trenches through, maybe that's better, maybe that's worse, I don't know. What do you think?
If you're through the weak layer, then it's better. I think you're less likely to trigger if you're through the weak layer. Yeah.
On those first couple images you showed with kind of like the pressure isobars there, you had really high negative pressures kind of on the uphill side. Do you think that's real or a result of the way you extrapolated?
Yeah, that was shear stress, and it's actually negative because it's in the different direction. It's not up. It's negative because it's in the opposite direction. Yeah.
So the take-home point from those slides are a shallow skin track is safer than a steep skin track. Is that right?
Because there'd be less penetration?
No, because of the pressure. You had the pressure bars were greater going uphill than going sideways.
Yeah, for the snowmobile and presumably yes for the skier as well. Yeah. Yeah. So as I get older, I like switchbacking more and more.
I was just going to make one comment based on what Dudley was saying about the boot penetration. Is I really think there is this balance between, you know, like Bruce said, if you're penetrating through, you know, if you're penetrating through, then you're not going to trigger something as easily. The day that Doug and I were making the measurements for the CT test, I felt like if we'd been on skis, you'd have been triggering collapses, but we were banging through with our feet. But then you get a harder slab, and when you penetrate through with boot compression, you can trigger something. And, you know, we had 2 examples of that a few years ago when we had post-control releases at Jackson Hole and at Snowbird. And both of those post-control releases involved people who were out of their skis. You know, they'd fallen, they were out of their skis, they were post-holing around, and that's when the avalanche triggered. So,
Yeah, I
something to
mean,
think about.
the hard slap is
Yeah.
even the Altoona thing when I went into the top of it, nothing. As soon as I took my skis off, walked down the pit, my foot went into the depth, boom, big cell.
So say you did high.
Go to Rick.
And fat skis are a good thing.
Fat skis are a good thing.